a mocking framework for JUnit testing. The second one is a system called ACA. I'm not familiar with it, but it's in Scala. And it's a toolkit for building concurrent and distributed applications. The third is Odoo, which is in Python. It's enterprise management software, so if you want to set up an HR department, use it. OpenCV, which is a library system in C and C++ for computer vision and machine learning software. You're not having any questions my whole life. That would be true. Don't know, but regardless, it's in Java. So I may have been mispronouncing it for some number of years, or maybe get it. So the point is not that we're going to use these systems for anything, but each of the challenge check is going to rest one of them. So I wanted to just say one thing about it. So be like, oh, where did this Java system for mocking that? Oh, okay. So, our first speaker is John Song. He will tell us about advertising predator optimization, a GPTP work group size for OpenCV. So, one more thing. If you ask a question, project. If you could try and remember to repeat it, because I think we're having a problem with people practicing aren't always doing it. They're going to cooperate.
Hello, my name is Antika, and I'm a master's student in China. CPS are keeping up in big workload. CPS continues to improve the key performance of continuous workload. Combined with the program methods, it allows to benefit computing on GPU. Python also considers that which is used for the majority of common projects. In a high general purpose computing to become an indispensable factor in a high performance computing. This slide shows the generic GPU architecture. GPU provides the intelligence by taking an manipulation of the architecture of GPU. It allows users to train general purpose programs against a large volume of data. Can be divided into two parts. Focus on GPUs and computational research on GPUs. Computational research is consist of multiple devices, which is and consists of multiple compute units. Compute unit is consist of multiple processing units, which is the base of the unit of the computation. From the OpenCV viewpoint, processing units can be seen as the worker items. And for the worker group, which is the several worker items of together, compute unit can be viewed as the part of the playing the role. For the bus viewpoint, worker item and worker group are sorted as flat and blank respectively. And focus on OpenCV. This slide shows the memory model of OpenCV. Host memory is on CPUs and global memory is on GPUs. Global memory is shared along our group, and local memory is shared along work items belonging to the same work group. And the further memory can be accessed by its owners, which is a structured work item. This memory is used as a task for the upper level memory. Between memory conflict between host to further memory and further memory to host. It is impossible to split the personal levels and directly transport the further memory aspect. A speed of memory transfer increases as the memory level goes down. This indicates that the memory transfer between further memory and local memory is the first step, and between the global memory and host memory is the fourth. Local working group size is the number of worker items belonging to the same working group. Since the worker items in the groups are equipped and utilized together. This term can determines an amount of calories applied to the target program. So this indicates that the value of local work group size determines the performance of the target program. Other officials allow users to assign a specific value to the local work group size. There is some limitation for this assignment. Maximum work group size, which is the maximum feasible value for the local work group size, is one of these limitations. To make the parameter feasible, local work group size cannot exceed local memory in a simple work group is another main factor that should be considered while we try to maximize the performance. This value is controlled by the local work group size. The group size is too small, it will underutilize the local memory of the CPU. And if it is too big, it will cause this text and flow IoT from the global memory. Since the ideal value for the local work group size depends on combinations of applications, the hardware is the only one. There is no way to set a single value to cover all the cases. So if you want to maximize the performance, values for our specific use. However, searching for the ultimate value of the local work group size requires the state triangle. Our solution to this question is online automated optimization process. Before we look at the details of online automated approach, we should know how it is different from the conventional offline approach. For the offline approach, optimizing process is a separate part from the real execution of the target program. After the optimization process is finished, the result values will be given for the real execution of the target program. Offline approach requires an additional effort for the optimization process, and it also can have bias for the given data, which are specifically provided for the optimization process. In contrast to the offline approach, amortizing time optimizations, online approach which we use avoid both additional efforts and bias. Firstly, optimizing process is divided into several steps, and this step is then distributed among multiple executions of the target program. This animation shows how this distribution is working, and the colored rectangles represent the single executions of the target program. Each execution contains a single step of optimizations which will be executed together. By doing this, we can avoid additional effort for the optimization process, and also can avoid bias. And also, we are more likely to avoid bias since we use the data that are used for the neural executions. Oh, sorry, I just skipped some steps. Actually, there are predetermined what is required, and after that, we use the best values found by the optimization process for the following executions. The amortizing findings and then apply to finding out the best values for the local group size, which is our cases. Our target of optimizations is GPU implementations of OpenCV. OpenCV is widely used contributory libraries, and it provides transparent GPU layers by using same interface for both CPU and GPUs, and also use default settings to assign a value for the local workload size. This indicates that user does not know anything about the implementation. Since our objective is to optimize the performance by controlling the values of local workload size, we need to expose these hidden values to the users. Exposing hidden parameters to optimize the performance is called big parameter optimization. For our cases, we expose hidden parameters to the outside by assigning values through the function parameters. By doing this, we can now explicitly control these parameter values. We apply amortized requirements on finding out the optimal values for the local workload size. Since we focus on 2D image processing case, local workload size is defined by a pair of two values, WGS1 and WGS2, which are values for dimension 1 and 2 respectively. Third space is limited by the decimal workload size, and the neighbors of the current solutions are calculated through addition or subtractions from the critical part of finding out optimal values for the local workload size is defined of the third space. We firstly calculate the WGS1, which is value for the dimension 1, and then by using these values, we found out the difference. There are 3 points that we should look at. First, we should check whether current calculated limitation values for WGS2 is smaller than the previous upper bound. If it is the case, we should redefine this value. This by using other range for the WGS2 values. After this, we should check out whether the new upper bound is smaller than the lower bound. Is smaller than the predetermined lower bound, and if it is smaller than the lower bound, we immediately return the predetermined values for the lower bound cases. And finally, we should check whether WGS2 and its neighbors are feasible. If it is not, we will repeat the generation process. We allow multiple visits to the same values to evaluate noise frequency evaluations. Evaluate with small search space. We use top search to encourage explorations and to avoid optimize. If the current values, which is local optimacy is visited more than the maximum visit values, the random start will take the place. For our experiment, our subject is complementary functions in OpenCV. We use 20 different pairs of images and templates. We measure the execution times of the complementary functions to compare the performance. For evaluations, we repeated matching for each pair 20 times. Each matching consists of 20 runs with the default setting, which is provided by the OpenCV, and it is followed by the 80 runs with the amortized optimization, and finally 20 runs with the best values found by the optimization process. Each running is repeated 3 times to smoothen the outliers. For the statistical analysis, we use many linear tests with different corrections and statistics. The results show that represent the sequence of control matchings, and the y-axis represents the execution times. As the graph shows, the improvements by using optimization process is quite visible. And for the statistical analysis, for many linear testing different questions, are given than the first technique. And for the statistics, our calculated effect size is smaller than 0.5, which means that optimized setting has a better performance than the first technique. This shows, now we look at the distributions of new pattern local group size. Graph A shows that the local group size does in fact compares to the certain values. And graph B shows that the local group size compares to different values for the different pairs. For summary, local work group size is the primary test that determines the performance of GPGPU implementation of OpenCV. Since these values is hidden on the multiple layers, we use deep parameter optimizations to expose these values to the user. And then we use some scientific planning to optimize these values. And the results show that by using this optimization process, we can find better values, and we can find better values than the first step. For the details, our key point is the environment. There can be some different parameters to affect the final performance. We are not sure about this. What kind of test data do you implement? So, only focus on the personality. You are awake, by the way?
Closing test on.
Telling us about the real no, how is that? Okay, we'll tell us about automated testing. I have to do your test out. I'm hoping I'm really all these are new because I couldn't get started on how to run anything. So the way the testing is going, it sounds like a good. Okay, thank you for being here. And hello, can you hear me on the last? So if there are any questions about the region, because I didn't hear it before, I'm going to hear a word. What we are trying to do here, what we try to do this person here, Paco, he is spiritual power, and the relating the task of a tool that can be used for me. Let me tell you about this step. This is a tool we developed for automating tests that we have to do. And it's an outcome of our European project. Now, those of you who are in European, if you can make some effort to get people from different countries to work together in projects, and then after the first finish, then you get a nice, sometimes you get a nice outcome. And the rest of the companies, you get a nice outcome, and then that outcome is forgotten forever. The future of the world is forgotten. So we don't want this to happen. So we are trying to get this back, which is an open source and it's available for there. You can download it, you can try it, and if you need help from us, and we would like to help you. And the philosophy behind this stuff is that you can use from any application that is calculated initially. So our idea is to once you system 3 or 4
access all the functionality of the, and the importance is that most applications have features, and this is the way that your customers are going to access your software. So if anything, if there are any errors, they are going to find it. And that this is going to be about you for the but you want to test from the user. It's something like but this is the source of the so the good thing about Tesla is it doesn't need software back to the manufacturer. How long we have the software here is that you scan the view and you look at it before a little bit, you think that what is in the there are patterns, there are many, there are whatever. And then it relies on a set of actions that the user can do. And selection and then execute this identity on another code that is going to tell us it's going to tell us if there was a problem. If there's no fault, we run more actions there, cycle. If there is a fault, we stop. And if no more actions are required or needed or whatever, then we stop it. And we get some metrics for what we have to do. If we have metrics, then we stop there, or else we start there are two places where the human data can interact with this. One is the action collection and the other is the protocols that are affecting several things amongst the other. The other code is going to tell you, for example, there are four that are anybody can see that this is a failure. But if you say 2 plus 2 equals 5, that kind of protocol requires a human to say okay. So you can apply this like a different interface. And so far, this thing here, the action selection, has not just textile, but mainly automated testing because multiple. And even so, if I talk, the software quality is so bad that even running so we have like successfully invested applications and then the intensity is very company. You don't think they're very hard. Okay, they weren't Microsoft small companies are the ones who really use it. You go to somewhere more at market. They don't like the idea of multiple. You feel that there's something clever. So what point of quality is going to be will make it discrete. Okay? And the other point is applying this for other things. So we started here, we have been very we have another student working on and going. This is a it's not very sexy. But this is okay. So the challenge is to be very interesting. At least I am aware of two. One is taking into account it means I have to look for the thing here because multi-one is error to be that my software is not responding. Oh, oh. Another challenge is I have to avoid testing the browser. I don't test the application is running. So I have to go out the filters and put some search bar to do one. Okay. At least it's actually challenges and some of them are not really silly, but actually
and the silly things like that are the ones that we are aware of. So, usually when we test them, we have those two things I told you. Where is the human interaction between this? One is the anonymity. And as I was saying, most humans are using imagination. So what they not making this process in the first approach, fancy, not running to peak. Learning is what is an easy way to start? How is it? The protocol in this type is a Java class that implements all the functions. You run test at once and you see what happens, and you do the protocol and you see what happens. So these are two things. Learning and not very this for most of the learning, but it's a model thinking policy. There is an action modifier, and this condition of an action, or wherever you learn afterwards, the action you have the policy is the agent that is going to follow it. The optimal policy is selecting the action you have to find values. It's able to compare with the expected behavior matches. You don't need to we have two parameters that we are going to see here. One is called matchable. And anticipation that how do we our usually what the quality is the percentage of code that we are testing to have executed over that's not what you are seeing. You are not seeing. So what do you do? You have to have states. And if the number of people in states, the window, the discipline in the course of an activity of action without information. And here the metrics that are more the position of state is if you have like a window, how many of the different boxes within that window you have to have a window. You can say yes, say just give me once, you do 100%. But if you use a window, you have to do that. Following all the functions, you need to do it. So we want to measure the need to do it. Now, what we are going to test all these in this application, which is as before, it is planning and it can be used for analysis, websites, marketing, so what we did was to deploy and install a number of those so the procedure is to install several versions and run the test. Because 5 more, just we see what is happening, we see the problems, we are doing the recover, and we do in that our election first, we see what happens, and then we have to calculate the difference. And we set that around the experiments, as I was saying, we can learn it, we can populate, it's very different combination that have to work this time. So in the end, we have four configurations, and then we compare with them. And what happens? So here we run the cluster voice test. We can compare the cluster voice with and then we compare them. So here we can see that this is random and this is we can see that these two are good. The first is very different, and we can see we are going to be better to get it better. We are always going to use it in the something relevant to the last phase. But in both of them, more or less you can see that they are the same thing. In this one here, the example is not. It's really because that and they all very much listen to this one. They feel it with all the points on this next one as long as and then also the resource specific problems in the so what do you do? Are the numbers? And in this case, the biggest number of failure is given up by this one, but also one of the units. So there's something to be different. Because not necessarily going more than the avoid the militaries or maybe for the militaries, then the knowledge that is the local knowledge. And then, of course, there's the and then replacing the activity API with whatever that's supposed to be. Okay, right? And up there, we will say that we're going to do the one program, which we are instead of this one. What do you see?
Oh, what? I didn't just read you. I think so. Yes. So to do that same lesson, keep working with yourself, I have to do it myself. I've got another sort of community things and what's your practice?
What do you think? So I think I opened this form, I started here just with this and then I did it. Wait, the first field doesn't make sense, just fill one field, or should I fill the whole field? There are many, but all the things you can access the value. So the human user, that's the human user, to be able to say, okay, let me find a mega action, which is going to be filling a offer. And that's very specific of the software. It's not generalizing the but that's the first one. Sometimes you can. Otherwise, you simplify it. And it doesn't make sense. Like you get a monkey there, you have a whole form, you name it, whatever, the monkey writes in there and that doesn't make sense.
Again. Now, what this is, transformation.
Thanks, hello, everybody. This work is applying genetic improvement, explain exactly to OpenCV, one of the challenge track software packages. Specifically designed to do fast and getting good results of it. And the second is a kind of philosophical idea about GMI and the weakness of GMI and how you can improve that. It's a collaboration with my colleagues at ECL, between this here somewhere. And I'd like to give a special credit to Bill Lander for line share this work. So for those of you who don't know what GMI is, essentially it is a fine search for software in order to improve it. The name comes from a generic program that we built to try and unfortunately monitor which we inherited, but it's basically actually in order to do that, we require search as a excuse me. So what do I mean by improve? Let's explain first. In this case, execution time and a whole lot of properties such as fixing and extending the thinking life and content properties. And we do that by applying using search, and we literally explore the cat space that possibly changes. We select those changes and find some variations and operators crossover to those captures. So you search the evaluation, principally to validate the results, make sure not necessarily look, and you have making better your right answer. A point about GI results in general, well, they can be really great because we get promoted by 8 students. So it does really weird things like change the lines down and you have no idea why it's better. But that's because compilers and hardware platforms are really complex and complex. And very counterintuitive to work out how a thing here affects the speed of the program that's running down on the metal. The flip side of that is it can be kind of difficult to comprehend what's going on as well. Why is that good? I'll give you some examples of that in this work. And that can perhaps make the largely human programmers accept the result. What we really like is human-leaded solutions. I have a long-term solution to this problem, which is to erase it by replacing human computing, but we don't have sort of human competitive algorithms of programming quite yet. Maybe 100 years or so. Let's consider we need to coexist with human code. GI is somehow more acceptable to human programmers. There's an alternative route, which is to kind of document what we do, and there's a paper called Flash, recommend reading from that. But in this work, I want to try and focus on making things more acceptable. So, does anyone know what block means? By the way, leveling block means. Okay, so we use the word block here from a science fiction novel. I don't know who it is. Oh, thank you. Excellent. Essentially, what block means is to understand something intuitively. So whenever you work on a bit of code, you say in your head and it's great, and then you come back and make it together, then you're blocking it and then you can block it. And I'm going to use that to explain what this work is about. So here's our human recognition system. Hopefully, in terms of blocking, we understand everything that's going on. Perhaps it's a smaller system, so we really have blocking our head at a particular time. More likely, we probably understand a bit of it. Perhaps a virtual slice of it. Come back later on, perhaps we don't. But let's assume for a moment that we understand all of it. Well, then we apply GI to our code, and the kind of problem very situation is we have these GI random shaped keys, switch keys like holes in there, which are unblocked. So as soon as we're looking at this, well, it doesn't really sound like stop with one there, but that's kind of counterintuitive to the program. We put these one down, it's easier to understand what I meant here. So what we'd really like is to separate out what GI is doing into a vertical ball next to our system, and then just have a world pattern here. But of course, we already have exactly this situation where we've unblocked this and we've got this, and that's when we use library functions, third-party libraries. And they're black boxes that you usually don't understand. And there's lots of them. 90,000 in PyPy's Python library, over 300,000 in NoPappyPlanch's JavaScript repository. So there's tons of them. This is really common. And they're growing rapidly. So we obviously like libraries. We don't have a problem with not understanding libraries. I'm comfortable with libraries. So the idea of this work here is to present GI as a library hacker. So to specialize that library for the way it's being used by an application, and to optimize it, in this case, for execution time, but other reasons want to do this. The library we choose is the OpenCV computer vision library, one of the challenge track packages. It's very huge, over 2,500 algorithms, written in C++, originally developed by Intel. Make it fast. They wanted to basically provide usable optimizations so people reinventing the wheel. So it's ideal in terms of if you want to find something that's fast and try and speed it up. The particular algorithm within OpenCV we looked at was image segmentation. You can see here an example of segmenting a polar bear, poor guy, and particularly the seed superpixel algorithm. This actually won a challenge for image segmentation. We offered a solution. So it seems like a good choice. Not only is it a fast library, it's an award-winning algorithm. Here's some more examples of image segmentation in case you haven't got the idea. Essentially, this is usually used as a pre-processing step at some higher level image processing AI technique built on top of it. So to apply our GI approach, the first thing we do We built an application that called the library, just very simply, so we could time what was going on. And then we profiled what was happening in the library with a file guide, and try to whittle down the lines that we have to worry about. The step in DI is reduce the problem size as much as possible. Here's a sort of abstracted version of the whole graph, and you can see here in the profile about a third of the time has been spent here. Yeah, well, maybe you can't see that. This is a very early profile that I did, not the stuff we did with the final software. Step 2, once we know where we're looking in order to optimize things, is we build a context-free grammar which represents our program approach. You'll see it in the work by Bill Langdon and Justina. But essentially what it does is allows to constrain the syntactic variation program in order to perhaps avoid some type problems, etc. Our population was 100, 200 generations, kind of arbitrary choices you often see in Bill's frameworks, just been used in the past. We take the 25th percentile of 11 measures of the execution time because it's quite noisy, so we're conservative here so we don't accept misleading improvements. Selection across every mutation. And one of these are being applied to practice. Yeah, the population patches, and we keep trying to improve them. And we may add in and insert these to a swap. Program. Grammar looks a bit like this. I can't explain it all in detail in the time I have, but you can see that, for example, anywhere you see underscore, as if, that's something we can swap in the grammar. So effectively, we take the grammar, program generates. We use the grammar because it allows us to constrain, for example, conditions can be replaced by simple syntax errors, compile errors by constraining. We trained the software on this very non-rigorously chosen image. This is Bill Langdon, Professor Langdon, I should say, on his own in the park. I think this one I have shot here. A very large picture we just used for training. It's not arbitrary, but it illustrates how reversible you can see in a minute, but quite a large image. And we ran that for 200 generations, and you can see at the beginning it's quite high in terms of what we managed to achieve execution time, but we quickly get down to more interesting. So we took the best raw individual from this last generation, which was composed of 22 different code changes, and the result was exactly the same as the one generated by the prize winning software. 7% fast on training data, confidence intervals was about 1% either side of that. So we then took the 22 changes and tried to whittle them down. This is a classic post-processing step in DI, and we did that by looking one factor at a time. So taking each of those parts of the diff and evaluating them separately. And what we're looking for there are robust changes that always make an improvement to the program. And those 6 are about 10% faster than the original code, so slightly better than the original, but within the original result. Great, okay, so what were those changes? Why did they make it faster? Well, these are different functions in the library that we optimized. The first one was to swap 2 adjacent lines, which seems to be a cache effect accessing the image. So the caching process we were training on was actually smaller than the image. And then duplicating for-loop tests seems to allow the compiler to do an optimization that was made before. Deleted case statements from a switch, which seem to be superfluous from what we can tell, but may have resulted in a shorter path in some situations. And so similar changes here. A very odd one in the 4x3 function. We basically invert a global variable and then we invert it again later on. But we assume that is some kind of compiler optimization it's enabling. Again, a bit like magic of Ruby, you don't really understand exactly why, given the amount of time you get to spend evaluating it. So, great, it segments those Frisbee image very well, but most images are not like a Frisbee image. So we then evaluated it on a corpus of 447 images, again, somewhat arbitrarily chosen, in that they were Bill's holiday photos. So if you went to a certain European EC event, you recognize these photos. I think that's the cathedral in somewhere in Spain, I can't remember. Essentially, nearly all of them are functionally identical to the original algorithm. It's just a couple of pixels different. The worst one is 71 pixels different out of a total of 8 million. And I can show you here, this is the image that was 70 pixels out. Here's the version produced by the original algorithm. Here's the version produced by our algorithm. There's the version again. You can see the difference. You've got very nice eye, but if I zoom in, you can see essentially here you have a slightly different line. Because it's been used for heuristic purposes, you're not going to be too bothered about it. So we're not worried. But then we wanted to test it further and from some images that were not determined by us. So we took this challenge, which led to the supersedes. It's being added to OpenCV in the first place. I think it's a set of images which were bytes, and for some reason they were loaded bytes, varying quality, but varying amounts of pixelation and stuff like that to try and test the algorithm. You can have a look at that online. Essentially, for a $20,000 award-winning algorithm, we managed to make ours 13% faster results and challenging. That's pretty good. Bobby Goose from UCL has very kindly put together some of those changes into pull requests. I don't think it's yet been accepted by the OpenCV project. But that is still not been accepted in its head. But the point being is that, again, this 10% seems pretty sound, already heavily optimized. Okay, so the take home here, I think, for us is, first of all, this idea that API-constrained genetic improvement isolates the changes. It's a very simple idea, just essentially targeting libraries or putting things in libraries so that you don't mess up the programmers correcting the direct code. Secondly, optimizing calls in OpenCV for image segmentation and achieving a speed up that's quite impressive over a competition winning bit of code which is already designed. And that's it. Thank you. As a library, right. So the document depends on from the other project then it's in doc before, it's in doc. So if you're a developer of OpenCV and you're trying to optimize your algorithm in general, then you can. You may choose to say that this might be progress around. So yeah. So those minority people, the polygraph. I didn't want to talk about the on spot, I didn't but essentially said that and we would be so really sorry, I just realized I committed this sin. So easy, so the first question was, is it blocked by the OpenCV program? And that can be the question that's a library, it's not the student doing a block. I agree with that, so we're definitely looking for an application program. And the second question was, how do you justify changes in pull request? And the answer to this question is so just a few changes. We didn't check the law so So the question is, are we going to provide an API to perform each competition? So the OpenCV already contains the original competition algorithm. So the API is already there. And there's other algorithms that this is the fastest that we try to optimize. We have tried to improve it to the customers about submission to the developers of some of the changes that we have. So if they accept it, that's great. Otherwise, you can contact us for your 10% faster version if you wish. You can give them you can provide that. Thank you.
So our last talk in this session. Right day, we braved the storm after we left South Carolina, which is actually being hit by a hurricane, to come tell us about challenges using Surface test generation to identify real faults in. Something was now that I see it, I can't see it.
Yes, now it's self-conscious.
Now I have no
so
idea.
I always called it mojito, and I remember it's right, but the logo is like mojito, so you can call it mojito.
I have no idea.
Yeah, no,
You're gonna tell us.
Pronunciations.
You're going to tell us about challenges by default.
Yes.
So,
Well,
regardless of the pronunciation.
I always call it mojito. I'm just going to continue to do so for now because that sounds great. So motivation, which you've all heard some version of today, but I'm going to repeat anyways because I like motivation. Software powers our society, right? Our phones, our computers, all run on software. Our cars run on software. The power to this room, our transportation systems, factories, all software, right? And no one here is going to argue the need to produce reliable, robust software, right? No one also isn't likely to argue with me that testing is invaluable in the West. Yet at the same time, testing is expensive, right? And as the complexity of software grows, the cost of testing only grows as well. And much of that cost can be traced to manual testing, right? The jobs like producing your input, producing stuff the output, automation can reduce that cost. And then have it is, of course, Surface testing. As the name implies, general process, generating solutions, store them according to some measure of distance from optionality, use that score as feedback to revise the population and continue growing it over time towards better and better. Right. Now, here's the thing: we usually judge our search case efforts in terms of things like all the branch coverage, fast and efficient, and that's great. But even if search case generation is fast, it's better than giving efforts always no matter what you do. Only really use if they are as effective at fault detection as many of them. We have is judged on mutations, synthetic faults in certain source code. And well, of course, that makes sense. You often don't have access to real faults in these experiments. Still, the jury is out there on whether a higher level mutation detection correlates to a higher level of high probability fault detection. So, really, what we want are better measurements. What we need are ways to check our efforts against examples of this. See if we do detect those. And that is where, in this case, mojito comes in. Mojito is a framework for creating mock objects. And these are objects that simulate the behavior of other objects when you're testing. And they're really useful when you're testing because what you can do is get capacity testing. Those dependencies, you can trust the results, right? And that lets you take a class, extract it, and test it on its own. Mojito is really one of the most widespread libraries in the world. One study named it the fourth most used Java library in the world. So it's all over the place. And Mojito serves as an interesting benchmark. First, it is a very complex project. Much of its functionality is actually related to the creation and manipulation of mock objects. So the inputs required by those functions objects, which is a task usually noted as difficult for test generators of every kind, for about as long as we've had test generators. The second factor is the Makino is a mature project. At this point, undergone over 8 years of active development. That means the Makino faults, particularly recent faults, are unlikely to be simple syntactic mistakes to solve them. Type of faults require specific, difficult to trade combinations of input and method. If a test generation tool can detect those faults, then it would be powerful enough for real-world use. And if not, or that we can study those faults and others like them, maybe we could write a few lessons over time to improve these things. So how can we get at those faults? This is where the key to this lies with what's called the defects for J fault. So if you don't know about this, this is a fantastic reading resource. It is a collection currently at, well, a bit from the current department here, but 357 faults from 5 open source languages. And all faults in this database meet 3 particular properties. First, the fault must be a fault in the source code. And for each reported issue, what we try to do is identify a pair of code versions that differ only by the minimum changes that are required to address that fault. The fixed version must be labeled as a fix to that particular issue, an issue reported in the bug tracker. And the changes imposed by that fix must be to the source code, not to other artifacts like your build system documentation. The second factor is the fault has to be reproducible. At least one test must pass on the fixed version and fail the faulty version. And third, the fix to that fault must be isolated from any unrelated code changes like refactorings. So if you have a fault and it meets all 3 of those criteria, well, then it may be added to the database. And that suggests that these are things that are really faults, not just things we've accidentally dug out and compiled or do something for us. For our purposes, however, is the defects for J can be extended to a semi-automated fault extraction process. So what we have done is we've added Makino to the project. And this consists of developing build files in Ant that work across multiple versions of the project, across the entire history of that project. We've extracted candidate faults. We've ensured that each candidate can be reliably reproduced. And that, again, we have at least one developer build test case that passes in the fixed version, fails in the faulty version. And then minimize those patches to distinguish those fixed and faulty versions to remove any unnecessary changes. Now in 2014, Makino moved to GitHub from Google Code Check. Now the GitHub contains all 8 years of version history, but it only contains bug reports for the past 2 years. Now, there's some trickery you can maybe get at those old bug reports. But we focused on the more recent issues so that we can really hone in on the maturity aspect. Those faults that are highly likely to be difficult to detect. So following this process, we extracted 17 faults from the total 8. And these were false concepts. They were false, but they were fixes to issues reported in the old issue tracker. We just happened to share an issue ID that overlapped in the tracker. Now we went through those manually, and since all 6 of those were actually false, and they met reasonable maturity and complexity thresholds, we also included. So 17 additional real faults this time. And of course, well, if we have those faults, we should do something. The studies have begun to assess the capabilities of these generation tools on actual faults from open source projects, but we really do need more data. We need more benchmarks to understand where the tools we have to sell and where they need to move. So in this study, what we've done is we've generated tests using the search-based heuristic framework on these classes from the computer project. So of course now we have these faults. We want to know A, can we mostly detect them? And B, if not, why not? So for each fault, what we've done is we've generated a test on the fixed version of the class. Right? This is done to eliminate the Oracle problem. Generate the fixed version, apply to the faulty version. If they fail, then we likely detect them faults. In practice, this would be like a regression testing. So to account for the non-deterministic nature of the Eagle suite, what we've done is we generated 30 test suites per fault, so 30 trials per fault. We use Eagle Suite's default configuration, automation of the fitness functions. And as these are classes where you can imagine the difficult to coverage, we've given a search budget of 10 minutes per fault, which is well over the 2 minutes often used in seconds. Now, after this, any tests that don't compile and that fail inconsistently or that fail on the fixed system are then automatically removed. In practice, that's less than 5% of each test suite. So for each test suite, each fault, we measure the number of tests that pass on the fixed version and fail on the faulty version. We also reported the achieved code coverage, the achieved coverage of test obligations. And finally, for each undetected fault, we took a look at the report and the source code to identify possible reasons for why we did not detect them. So, without further ado, our results, and the results are that one of those 17 faults were detected. Numbers don't really matter, but in any case, this is fault number 2. This particular fault, which revolves around the hand values, is a really, really good example of what we're good at, right? The code fix had some conditional behavior to handle that time of input. While we're guided toward negative time value. Just consistently. So that's great. Just sensing the button there. However, EvoSuite failed to detect the other 16 faults in the system. This is a natural question, but why not? What failed? 5 reasons I'm going to go over. There are naturally others, but 5 in particular. So while EvoSuite is often able to achieve quite reasonable levels of coverage, it is quite low. Take fault number 12, it's case where we line 11% branch coverage. While coverage naturally does not guarantee fault detection, if you don't execute code, you're probably not going to reveal a fault. One reason coverage may not be achieved is that the code itself offers no good guidance to the search and selecting better test suites. Functions are naturally designed to measure the distance from optimality of the generated test suite. So in this case, with this fault number 12, it's a good example of this. There are 2 branches in some use case of operator data. It's a good way of determining that distance in the balls into the search. This is like the flag. Every guy that search can be done in the water. As I kind of alluded about earlier, one major challenge with text generation is generating input for complexity. You want to generate objects and then other objects require complex objects. So even when pieces of coverage is high, generators may have difficulty producing very specific input. So fault number 13, and this is a bit of a busy, but this occurs in Buffalo's verification capabilities on both a method call. The key itself has an embedded method call. The call is generating 2 mock objects, 1 object within a call to the second. Pretty unlikely to stumble where achieving coverage isn't necessarily going to suggest using the server. Really, here, there's been very promising work in using parameters to produce complex input. This helps us generate these complex objects. And we have these scenarios. Now, this sometimes gets us into more trouble. When we're generating tests, unit tests instantiate the object and call methods, right? And at times, when you instantiate an object, well, you have to provide it with input at instantiation. It doesn't have to default constructor. This fault number 3, many of its codes use a container in a single method. A method that therefore, English linguists not only fails the others, but it can't be broken at all because when it goes to class and class, how they look at the answer, many of these attempts fail due to dominant structure. In no search will be something methods of an object. Now, fault number 5 revolves around undesired dependencies on the data. This is a fault, and fixes for it require clear communication in the system. However, coverage of this code will not be revealed as fault. Really, it is only detected when data is removed from the password. So this is an example of a fault that depends on environmental factors. In this case, the class path uses the and we are seeing now testing language that do with environmental factors. Things like file system access, but more examination of these kind of factors is needed in future testing releases. And the class is affected by fault number 6 after another period. Mock objects can be configured to return different values based on type function. Due to this particular fault, a mock can produce a value in certain data types when null object is passed to the changes to this fault are primarily methods that themselves don't require anything. Rather, they're called by marking a value. Because this is a case where, under normal circumstances, the university is absolutely used to require that. However, this is not more than the dangerous side of this. You will need to direct it to generate tests, but a class that depends on the faulty code rather than directly testing the class with. Right? So some consideration does need to be given to classes that use to generate tests, and in the integration cases like these, dependency. So, when they enter this with a challenge, take project, do something interesting with it. In our case, you would answer a question. Given current state of the art, can we detect these faults? And the answer was, well, you're not really this case, but you can see where they go from here. So I would pass this challenge on to you guys. What can we do to detect these faults? And to facilitate this, well, have these faults. If you want to access them, head on over to defects.org. Where we have been busy since this initial study. Now we have 17 to 38 faults. We pulled 21 more from the old Google code that you got there. And thanks to help from Dusty and Jose back there, they played this in. We have supported data communication testing for test generation for code coverage, all those very consistent. So thank you. Hopefully you guys can do something cool with this as well. And let me know if you have any questions. The last person that has to yeah, so it's saying we had 17, now we have 38. Oh, you mean can you do since the current version?
Yeah.
I have not. No.
Right, I mean, it's on the old one. But we're running on
Yeah,
the
this is the old one. It's like, it'd be cool. Hopefully, that's it. Yes, that's what I'm doing. So if you make a video probably the context of the properties so you really that's the one that you have to SSBSE. That's actually absolutely. So it's one of these things saying that being a little harsh with the instinct. We're only going to be primary question and these things. Yeah, I mean, good balance. No, that's actually not true. I would motivate you, right? So he motivated. No, obviously there's all sorts of uses for everything. It's not necessarily how we respond. But in the ideal world, I'd rather than sitting down and throwing out spending weeks on testing, we can just throw in this and some other question that you can add. I think the flexibility we can work on that is exactly the same consistent code that we so I think the model is about faults that absolutely. Yeah, yeah. Any other questions? All right, so I'm assuming Claire wants me to do that.
No, I don't. No,
Okay. Hello everyone. Let's start
Do you
the
want to stream this as well?
meeting. And just so you know, there is a steering committee. The steering committee members are on the side, Andre Archery from Norway, Nancy Barros, Brazil, me. And I'm the current chair of the steering committee, which is why I'm going back. There, he's that. Going to do that. Mark Harmon, Federica, Ed Sosa, David White, Shin Yu, and Brandon. And I'd like to start by thanking the organizers on behalf of the steering committee. I heard we have 72 registrations, which I believe is a new record. The last record number was 65, so thanks very much. So as you're probably aware, the mission of SSBSE is to help us build and grow a community, to share ideas about problems and solutions, develop research, and to build a critical mass of interaction. And in order to do this, SSBSE has an interactive concept discovered by the steering committee. There are 9 members to the steering committee. You can also find the data on the website. It's usually hidden if you go on into the work and you recognize the committee or the box of the steering committee to read that. They're hidden at the link to the data. And the steering committee decides on strategy for where to organize it. And the steering committee is selected by you, by the community, and that's what we're doing right now. Now, if you pay close attention to the first slide where I put the steering committee
don't have 9 members, but currently have 10 members, which is because last year in the election we had a tie, and then the decision was made to temporarily have a slightly larger scale. So the rules, the starter rules, how for the steering committee is organized, and every year 3 steering committees go off. There is a limit of 2 terms in secret if you serve on the steering committee, but you have to take a break before the individual to be elected again. And the procedure to be elected on the steering committee is that so now anyone in the room can nominate anyone else in this room. Somebody has to second the nomination, and the person who is nominated has to accept the nomination. We will continue this until we run out of nominations. Then each of the nominations will have to give a photo of those nominations or election address. So it's the minute, the person, we will know to what the election and what the rules of what is used for further and for the future people are. And then each of you will have now a piece of paper in which you can write up to 3 votes. They have to be a different group. You can just say in more than one. You don't have to look for 3. You can also look for 1 or 2 pages if there's that. So out of the current steering committee, the following 3 people I have to roll off: Mark Hyman, David White, and Glenn Young. As of this moment, the steering committee looks like this. But that is only until the end of voting, because we're going to select a new members. Anyone who's in the room can be. With one addition, maybe this is, I think, the first time that the rule that somebody cannot be re-elected applies, because Mark has served 2 consecutive terms. He's also not here this year. So this will be the first time that the steering committee does not have Mark as a member, but that the rank Mark, there must be strong commitment to the committee. And I'm sure that they'll be elected again next year. So, are there any questions about the process? Yeah. Any more questions? Yeah. Okay. So I've listed the rules again here. If you think that somebody is suitable and should be elected, you know, nominate that person. You have to second the nomination. Then we're going to draft that person very second. If there's no other further questions, I think we can start with the nomination. Let's do that. Okay, you know. Okay, does anyone second?
I second.
Do you accept your own nomination? Okay. So you nominated Tim. Does anyone second this nomination?
Awesome.
Great. Tim, do you accept? Okay. Does anyone second it? Right. You accept?
Yes.
Actually, Tim, I just saw your tweet earlier. You called me Gordon Farah. Okay. second. Great. Okay.
Yes. A second. Okay. Yeah. A second.
I think that's basically this one. Last time. Is that large enough? No, I think we'll do maybe 1 minute per person. We'll just come up here, one after the other. So this is yours, who you are, and why you're a good choice to be on the steering committee. Marked up and published by 2000 together. One of the earliest applications, radar scientific requirements. So just to prove to you I'm not going to be possible. Right now I'm editor TSC, ISP, journal, and I think I've been promoting towards the TSC a hell of a lot for many years. I'd really like to do that more.
Yeah, so yeah, I'm Aaron Cosentini. So first of all, I'm glad to see already two of my very recent PhD students were very active in the SBSE community already in the list. So I'm Mohammed, and I feel a bit bad to compete with my students, but foremost, so yeah, I built a group on search-based software engineering, and we're active in the area since a couple of years now. now, and we are working on different things from requirements and to testing. I have been PC co-chair of the twice at Pico for the SBSE track, and I'm now the general chair of SSB 516, and I'm trying to do my best to promote the physical software engineering area in North America, and then we have a lot of publication events in the area, and I'm guest editor of many special issues in the SRP transaction on evolution computation, the IST journal, the empirical software engineering journal, and recently we have another one in the IEEE transaction on emergent profit and compression and intelligence, and all of them around physical software engineering, and the goal is to promote this area, and maybe after 2 years we will become maybe a conference. We are now a symposium, and the community system certain activities that it will maybe in the future become more expanded, etc. That's what we want. Thank you.
Hi, I'm Greg. I'm still going to wave to you while walking up front. In addition to being a loudmouth, I have been involved in researching software engineering, software testing, and search-based applications since 2008 now. I at the search-based testing workshop in 2014 that Mark and Phil asked me to take over, and I co-chaired the 2015 and 2016 workshops in search-based software testing at SBSE, where I'm also now the steering committee chair for that. So I might as well continue working toward taking over the world of search-based testing. Nothing has been lit in fire, no one's died yet in these workshops, so I think they went pretty well. And I'm eager to continue promoting our community and doing this wonderful, wonderful work. So thank you.
Hello, everyone again. I'm Greg White. I'm an RA at UCL. I've been on the last few years, and it's been a real action. I've been working in search-based software engineering for 10 years now. I've worked on the two major projects coming from the British Research Council in that area. I did some foundational work on GI, so I guess that's the area I work most in the field. And I also hosted the workshop in GI at Gecko. I ran a workshop this year in London, some of you attended, on the challenge track here. I think that's one of the areas I'm really interested in, to improving that and working on that next year. The steering committee is to make sure that we can attend the conference, particularly in terms of getting some getting the big hitters here every year and have some ideas in terms of outside of things who are writing great journal articles, but not necessarily always attend SSBSE and make them more accessible to them.
Okay, so my name is Ali Oli. I have been working on search-based software engineering for more than 5 years. I'm involved as PC member in a couple of conferences in for the last few years. We also organizing a workshop on software manufacturing and also distributed a special issue on manufacturing on IST journal. So yeah, I'll be continuing supporting promoting search-based software engineering for the next couple of years. Mainly my interest in software quality, websites, quality improvement, and software process improvement as search-based software engineering. So I'll be glad to continue promoting engineering.
Hello everyone, my name is Mohammed. Yeah, I just graduated from the University of Michigan and I'm a student of Santini. I'm really happy. I'm really an honor to be in this list. I'm really excited to be in this list, but especially this is my first time being in this community, and I know almost all of you through the papers, and I really was excited all the time reading the papers. And I was recently appointed as assistant professor at the University of Manchester Institute of Technology. in the software engineering department because they want to promote software engineering, search-based software engineering. They want to bring more computational search into the department. And probably they picked me because I have over 10 papers during my PhD, which are all search-based software engineering papers, including manufacturing, testing, bug localization. And of course, I'm not a perfect search-based software engineering. I'm going to keep promoting search-based software engineering to my students and to my research. Thank you very much.
All right, so as a reminder, you can have cast up to 3 votes on your ballot that you should have. And we're going to collect them in this box. And because I don't want to stand in the way of you and this lovely weather outside, we'll count it after the session and announce it tomorrow morning. The outcome of the Pardon? Yes.
So press arrow for this here. Okay.
But
Okay, everyone is better. You don't need to.
Okay, yeah,
everyone.
everyone.
Okay.